Hello, this is section 11.2 and we are going to talk about vectors in 3 dimensions. Up to this point of our study of calculus, we limited our calculations to functions, curves, and vectors that can be plotted in a 2-dimensional xy plane. However, a 2-dimensional coordinate system is insufficient for modeling many real-life examples. For example, to describe the trajectory of a jet gaining altitude, we need two coordinates x and y to measure east or west, or south or north. We need another coordinate z. By adding a third coordinate and creating an order triple xyz, the location of the jet can be described. The set of all points described by the triples xyz is called 3-dimensional space, or xyz space, or R3 space. Now let's take a look at XYZ coordinate system. So a 3-dimensional coordinate system is created by adding a new axis, and we call this z-axis. To the familiar XY coordinate plane or coordinate system. The new z-axis is inserted through the origin perpendicular to the xy axis. The result of a new coordinate system is called 3-dimensional rectangular coordinate system, or XYZ coordinate system. The coordinate system described here is a conventional right-handed coordinate system. If the curled fingers of the right hand are rotated from the positive x-axis to the positive y-axis, the thumb points in the direction of the positive z-axis. The coordinate plane contains x-axis, y-axis is still called xy plane. Now we have new coordinate planes like xz plane or yz plane. Let's take a look. You can see here the green one is YZ plane, the gray one is XZ plane, and the blue one is XY plane. So you can see, and all planes intersect at the origin, and we have in the XY coordinate system we have 4 quadrants. Here we have 8 octants. So you can see, at this picture how they are located. Now, how do we find the point in the XYZ coordinate system? The points where all 3 axes intersect is called the origin, and it has the 0, 0, 0 coordinates. And order triple A, B, and C refers to a point in XYZ space that is found by starting at the origin, okay, and then moving A units in the x direction, B units in the y direction, and C units in the z direction. With a negative coordinate, you move the negative direction along the corresponding coordinate axis. So here you can see, how to locate a point within the coordinate system. Now, how about if we need to find, for example, point 3, 4, 5? Well, as we explained previously, we move 3 units into the positive direction of the x-axis, 4 units into positive direction of the y-axis, and then 5 units up, which is the positive direction of the z-axis. So here we have the points located within the XYZ space. And of course, well, if we take a point, another point, point -2, -3, and 5, then we go 2 units into negative direction of the x-axis, then 3 units into negative direction of the y-axis, and then 5 units up. So this is fairly clear. We just, add the third coordinate here. Now, the equations of simple planes. The xy plane consists of all points in xyz space that have a z coordinate of 0. So basically we can place our previously learned xy plane into the three-dimensional space and say, okay, if this is the in third dimension the coordinate z is just 0. Similarly, the xz plane has the equation y equals 0, as you see. And yz plane has the equation x equals 0. Planes parallel to one of the coordinate planes are easy to describe. For example, equation x equals 2 describes the set of all points whose x coordinate is 2 and whose y and z coordinates are arbitrary. So this plane is parallel to and 2 units from the yz plane. Similarly, the equation y equals a describes a plane that is everywhere a unit from xz plane, and z equals a is the equation of the horizontal plane a units from xy plane. So this is the simple equation of the planes. Now please, based on what we just said, please determine the equation of the plane parallel to the xz plane passing through the point 2, -3, and 7. How would you start? Give yourself a minute and try to, pause this presentation and try to figure out, how would you start? Well, in order to determine the equation of the plane parallel to the xz plane and passing through the given point, we know that the points on the plane parallel to xz plane have the same y coordinate. Therefore, the plane passing through the given point with has y coordinate equals -3. So basically the equation here is y equals -3. And here it is, the graph to it. So you can see how this plane look like. Now let's talk about the distance in XYZ space.